Okay, so we're going to begin our next section, section 1.2, segments and congruence. Okay, segments and congruence. And so the question that we want to answer today is this: what does it mean for two segments to be congruent? What does it mean for two segments to be congruent? And the first thing I would like you to do is I want you to draw AB, segment AB. So check out my cool symbol now, right? And segment XY, so that they are the same. All right, so go ahead and try drawing something like that. Draw AB and XY so that they are the same. And you know what, we'll just, the same length. We'll say the same length. Okay? So I might draw a little point A here. I might draw a little point B here. And then connect them with a little segment. And then I might draw like X over here. And maybe Y like over here. Connect those with the segment. And so some of you guys are probably looking at that and going, wait a minute, they're not the same length, right? They're off. And yeah, they probably are actually, because I just eyeballed it, right? So if I was to take a ruler and to measure how long this is, and then another ruler and measure how long this is, they'd probably be off by a little bit, right? In geometry, you know, if we had to always like measure it with a ruler and draw it exactly the same, that would take a lot longer than what we want to do. So what I want to introduce to you today is a way to be able to tell that these guys are the same length, right? And the way that I wanted to start off today is just by telling you some ways to write that these guys are the same. So one thing you can do, so what does it mean to be, or you know what, how can we show that they are the same length? How can we show that they are the same length? So here's the first way, is to show that they are, and then here's the new word that you're going to learn, is congruent. Congruent. Okay. Congruent, this is a fancy word for same length or equal. Okay, to say that they are congruent. Okay, the second way to show that their measures are equal. Okay, to show that their measures are equal. So the actual measurement, the length of the segment. And then the final way, so to show that they're congruent, to show that their measures are equal. And then the final way is just to mark it on the picture with the correct symbols. All right. So let's go ahead and practice that. So the congruent symbol is given by this mark right there. Okay. And then the equal symbol is given by this marking there. And then I'll go over the third one in a second. So the way that we show that AB and XY are congruent is by going like this. We say AB, and then we have to put this notation on top, is congruent to X, Y. To say that AB is congruent to XY. So the way that we read this, AB is congruent to XY. Segment AB is congruent to segment XY. Okay. Another way we can write this is to show that their measures are equal. So the way we would do that is AB equals XY. Okay, and the way we read that, the measure of AB is equal to the measure of XY. So there's a slight variation, do you see that? But both ways we're able to say. Okay, we're allowed to say these in both ways. So segment AB is congruent to segment XY, and then the measure of AB is equal to the measure of XY. The third way we can do it is to mark it on the picture with the correct symbols. And so one thing we can do is if we have our AB here and our XY here, the way that we can mark it with the correct symbols is by putting something like this to show that they are the same. Okay, some other common ones you might see, right? If you have two like this, then you might just see one little marking like that. And so all three of these are ways to show congruency, to show that they are the same length. All right, and so with that, I want to introduce to you something called a postulate. Something called a postulate. And in math, a postulate, we're not going to go too much into proofs this year, but a postulate is just a rule that we accept as true. So just like the point, the line, the plane, in the same way, when we introduce what we call a postulate, we don't have to argue about whether it's true or not because everyone accepts it as true. So with these segments, the postulate that I want to introduce to you today is called the segment addition postulate. The segment addition postulate. So for example, if I were to draw a segment from one side to another, and I were to call those guys F and H, and in between there was a G. Not right in the middle, you know, that doesn't really matter, right? So what does a segment addition postulate say? Well, if I were to ask you, let's say this is like 3, and let's say this is 10, right? Then the way that I would describe this is FG equals 10, GH equals 3, and then is there a third measurement that you can find for me here? So if FG equals 10 and GH equals 3, is there a third measurement that you could find? Well, some of you guys might see it. If I take FG and if I take GH, and if I combine them into one big one called FH, I can conclude that the length of FH would be 13, because 10 plus 3 equals 13. So here's what the segment addition postulate says in words. So if G is between F and H, okay, by the way, F, G, and H are, and do you guys remember that term from the first lesson? Collinear, right? If they form the same line, then here's a way we describe it. FG plus GH equals FH. FG plus GH equals FH. So how do we read this? So we would say from our notation here, right? So the measure of FG, or the length of FG, plus the length of GH is the length of FH. Okay, and that is the segment addition postulate. So let me just make a note about this. So you cannot say, well, so let's say this, notation. So in geometry, notation is important. Notation meaning the way that you mark symbols and stuff, the way that you show your math, this is really, really important because it's easy to make a mistake along the way. So like, for example, I said that AB plus BC equals AC, right? That's a segment addition postulate. AB plus BC equals AC. So this is a big no-no. So you cannot say segment AB plus segment BC is congruent to segment AC. You cannot say this. Okay? When it comes to things like measurements, right, the lengths, you always have to use this kind of notation and not this one. If you mark this, it will be wrong. And as we go deeper and deeper into the geometry, you'll see where things fit and where things don't. So where these congruency symbols fit and where these ones don't, okay? Well, I just want to do a quick example with you. So on page 13, there's a problem there, number 30, we'll go number 32. And it's called science. And you know what, let me just put that on the screen. So number 32 right here, it says, the photograph shows an insect called a walking stick. I hate bugs, by the way. Use a ruler to estimate the length of the abdomen and the length of the thorax to the nearest quarter inch. About how much longer is the walking stick's abdomen than its thorax? All right, so if we eyeball it here to the nearest quarter inch, so we would say the abdomen is about 1, 2, and then looks like this is 2.5, so this would be 2 1/4. And then thorax would be, whoa, okay, so let's see. 3/4 plus 1. Oh, this is a bad example. I don't feel like doing this. Okay, so 4 and whatever this is, 4 and 4.0, 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 parts. So 1 out of 8, I think. 1 out of 16. Okay. So let me pull this guy down, and then I'm gonna just make some notes here. So for number 32, we can see that the abdomen is equal to 2 1/4 inches. Yay, fractions. And then the thorax is a little tricky to find, but one thing we can see is that it's 4 1/16. So 4 1/16 is a measurement on one end, and then it starts at 2 1/4. There we go. And so 4 1/16 minus 2 4/16. So 3 17/16 minus 2 4/16. Don't you guys love fractions? And so that equals 1 13/16 inches. So there's the length of the thorax. There's the length of the abdomen. The question asks you, how much longer is the walking stick's abdomen than its thorax? Well, so the abdomen is longer for sure because there's a 2 there. And so now we just got to do some subtraction here. So abdomen minus thorax. Right, the length of the abdomen minus the length of the thorax. 2 1/4 minus 1 13/16. So 2 4/16 minus 1 13/16. So we borrow 1 20/16 minus 1 13/16. And so there, the ones are gone, and we're left with 7/16 inches longer. Okay. This went from a segment addition postulate to a fraction problem. Okay, let's try one more. So on the same page 13, we see number 20. Let's go with number 28. Okay, so page 13, number 28. So there is the problem right there. Point S is between R and T on RT. Okay, so S is in the middle. Use the given information to write an equation in terms of X. Solve the equation, then find RS and ST. So let's draw a picture. So S is between R and T. So there we are, right? And so we know our segment addition postulate. Which says that the length of RS plus the length of ST equals the length of RT, like that. And then in this problem, we're given RS as 2x plus 10. So Rx is given as 2x plus 10. And then ST is given as x minus 4. And then the entire length, RT, is given as 21. Like that. All right, so according to our segment addition postulate then, we can just put all the algebraic terms into the equation. So 2x plus 10 plus x minus 4 equals 21. And then we combine like terms. So first we can get rid of the parentheses because there's no negative symbol or anything to worry about. So plus x minus 4 equals 21. And then I want you to think about it like we're cleaning up a house with 2 rooms. So in one room, you put all the letters, the variables, and then in one room, you're gonna put all the numbers, right? When you have a messy house, you take all the toys that belong to one person, you put them in their room, and then all the toys that belong to another, and then put it in the other person's room, right? So that's what we're doing here. So all the terms that have letters are 2x plus x, and then these guys are the numbers that we are trying to simplify. So 2 dogs plus 1 dog is 3 dogs, so 3x. And then positive 10 minus 4 is equal to positive 6, equals 21. The next thing we want to do is we want to move all the numbers to the other side. So we want to subtract 6 here, subtract 6 here, and then we're left with 3x on one side, and that equals 15. After that, we can divide by 3 and divide by 3. And then what are we left with? X equals 5. And that's our final answer. All right. So here, those are just a couple of examples that you might see as you guys work through this stuff. So just to review, what does it mean for 2 segments to be congruent? Well, it means that they have the same length, right? And if they have the same length, we can't always draw them accurately. So we show that they're congruent by using symbols like this. We can also show that their lengths are equal, and we can also mark them up in this way. And then what we can do is we can take the lengths of these guys, especially when they're collinear, and we can add 2 measurements together to get the third. That's a segment addition postulate. And yeah, okay. So that's our lesson for today.